Hi, in this video we will understand how we can handle corrupted data in PySpark. First we will understand how does the corrupted data looks like. Then we will understand what are the options to handle corrupted data in Spark. And then we will do a hands-on where we will see it in action. So let's get started. First, let's understand what can be a corrupted data. So let's say this is a JSON file, and in a normal JSON, so everything it is wrapped in double quotes, both key and value, and then separated by a colon. But let's say in this particular record, the double quote here it is missing. So this makes it a corrupted record. And then in this example, let's say the colon between the product and the null, it is missing due to some reason. So these two are corrupted records. So this is how corrupted data looks like in JSON, and the data may be corrupted in CSVs as well. So let's say this is an example of CSV file, and in this case, let's say this column, it is normally expected as a numeric value, but in this case somehow the value XX came here, and maybe some of the column it has some missing column at the end, or like there can be any other type of mismatch in the data. So this is how the corrupted data will look like. Now let's understand what are the options to handle corrupted data. So there are two options in Spark. One is that we can specify read modes while reading any file. So by default the mode is permissive, and in permissive mode it will insert null data for the corrupted records, or it will store the data in raw form, and then it will add an additional column which is called as underscore corrupt underscore record, and that column will contain entire information about the corrupted record, and other columns will be populated as null. And apart from the default mode, there are two other modes also. So one of them is FailFast, which used to be default mode in older days. In this mode, the process will fail. It will throw an exception that the file is corrupted. And the third option, it is DropMalformed. In this mode, what it will do is it will not load the corrupted record in any way. It will silently ignore them and only load the correct data. So that's why it is called as DropMalformed, that whatever is malformed or corrupted, just drop it and don't care it. So in this case, we will not know if there is any corrupted data. It will be simply be ignored. So this is option 1, and where we can specify these three read modes. And there is this option 2 where we don't specify any of the mode, but we specify this option which is called as bad records path. And in this path, the Spark will write the bad records as JSON files. And this path, it can be a central location where we can write any bad record from any kind of files. So we will see it in action. So these are the two options we have. Now let's see these options in action. First, we will try to read this corrupted JSON file. So this is my Databricks workspace, and this is where I have uploaded that file. First, let's try to simply read it with the default mode without specifying any other option. So here I have only specified that it is a JSON data, no other option I have specified. So let's see how the output looks like. Here we can see that it has automatically added this column like underscore corrupt underscore record, and whatever corrupted record was there, that in this case column was missing, and in this case the double quote was missing. So those two records it has put up completely here, and the actual column it has put up null because it was not able to map them. So that is how this data looks like by the default mode. So if we don't know like how it is handling, then we may be confused like why there is this additional column. But this is the default mode. Now let's check out the other two modes. So in case of DropMalformed, this is how we specify it externally, like mode DropMalformed. And in this case, it has simply dropped those additional corrupted records and only loaded the valid data. So the records, corrupted records are simply ignored. And then the third mode, which is fail fast. Let's try out this one also. So in this case, it will fail like expected. It is saying like malformed records are there, so it cannot proceed. And it is suggesting that if we want to handle it, we shall set it as permissive. So permissive, it is the default mode, and we can specify it explicitly as well. So it is always good to specify explicitly so that in future, if the default changes, the output will still be expected. So this is how it will be handled in JSON. And now let's understand how it will be handled for CSV. So this is our corrupted CSV file. It doesn't have any header or anything. First, let's try to simply read it without specifying anything. So in this case, we can see that it has loaded the data, and because we didn't specify the schema, it has put up this invalid value also and made this column a string. And column names it don't know because we didn't specify the schema here. So in the next option, let's specify the schema explicitly. So here we will attach this schema, like this is the column name, this is the data type, like that there are others. And then while reading the data, we specify the schema. Format is anyway CSV, and option, it is like by default also it is permissive even if we don't specify it, and then it will load it. So here the point to notice here, it is that this corrupt record, this is something we had to specify explicitly while creating the schema. If we don't specify it, this column will not be created and only this kind of data we will get. And in this case, one more thing to notice is that whatever is the corrupted record, so entire record is put up here, but if the value it is missing or something, let's say here the last value is missing, in this case like the XX was there for the numeric column. So whatever is just the missing or invalid piece, that part it will put as null, unlike JSON where it had put everything as null. So here only invalid cell it will put as null, and rest of the records it will put up, and underscore corrupt record, that anyway it will put up there. So this is how it will work in CSV, and like we specified in JSON, here also like we can specify it explicitly, we can make it fail fast, the code will fail, or we can mention drop malformed, and in that case the record will be dropped automatically. So if we let's just specify drop malformed. So one additional thing to notice about CSV is that in this case, even though it will ignore the corrupted record, but if we have specified this column, then it will be of no use because it will be always null. So if we are specifying this, it is always better to like remove it, or if you specify it, we shall use permissive mode. So that's how it shall work. Then so far we have discussed the option 1, all the 3 modes which we can specify, and now let's discuss the option 2, where we don't specify the mode but we specify the bad records path. In this case, I'm reading the same CSV file and I'm not specifying any mode, but this is the path where I want to store my bad records. So this path I have specified. Let's run this code and let's see what happens. So in this case, it has like not loaded the bad records. So the data that we are getting, that will only be only the valid data, and invalid data that has been written silently to this location. So now let's check out this location, what exactly has been written. So this is the location that we had specified, and if we open the latest one, So this is how for each date wise and timestamp wise, it will first create folders. Inside that, it will create a folder bad records, and then it will create a file. And surprisingly, it doesn't put any extension to the file, which I didn't really like it. But this actually the data inside this file, it is stored as JSON. That we came to know like after we open it. So let's open it in local so that we understand what is there inside this file. So this is the file which it has created, and here we can see that it has three things: the path of the file which has the corrupted data, then the record, which record is corrupted, and then a reason like why this record is corrupted. So this is the additional information that we get in this mode, which we don't get in the previous mode. So this is how the data looks like, and if we want to check out this data in a better way, so let's load it in Spark directly so that we can understand it in a better way. So this is the same path I have specified. Let's read it and let's display the data. And in this case, one thing to notice here is that I have specified this additional option, which is recursive file lookup. So what this option does is, by default Spark will check only this path. By this path I mean this path that we have specified. As here there is no file, so by default it will not load anything. But if we specify this option, then it will go inside each and every folder, pick up all the files and then show the data. That's why this option it is useful here. And as we were talking about here, there are three things like the path of the file that has corrupted data, the record itself, and the reason. So here the reason it says like bad record cause wrapper, which doesn't give much info. In this case, it is saying like number format exception and saying like for input string this one. So this XX it is not able to format it as a number. That's what this error says. So this reason it may or may not be helpful depending on the type, but definitely this is a useful information to have. And also in another scenario, this bad records path option may be useful. How it can work out is in option 1, when we handle it using permissive mode, so we get this as additional column. So we will get it in our output data frame, and then how we handle it, either we can filter out based on this null or not null, or we can write it separately. We can segregate the data between valid invalid, but we need to do that for each table whenever we are loading. But in this case, what will happen is, for all the tables, if we specify the exact same path, the corrupted records will be written in a central location, and then we directly can come to know like for which file what is the reason and what is the record which is corrupted. So this is pros and cons of both the option. So in this second option, we get the reason plus a central location for all the corrupted data, but in option 1 we don't get the central location, but for each table we get the information record wise separately. So we can use any of the option depending on the scenario which is best suitable for a given use case. So this is all I had to share about handling corrupted data in PySpark. I hope you got pretty much good idea. So try it out and then let me know. Thank you. Bye bye for now.